Hi everyone. So we're going to work on Workbook 2.2. So make sure you have your notebook out and let's start a new page. Title it Workbook 2.2. Okay. Oops. So I'm going to be going back and forth between my notebook and the course. So numerators other than 1. So you have experience with the rational exponent that have 1 in their numerator. For example, 5 to the 1/2 equals the square root of 5. So this is what we did in the previous lesson. Now you'll learn about exponents that have numbers other than 1 in the numerator. Some expressions and equations can contain both radical symbols and exponents, so like the square root of 5 to the 3rd power. Because taking the square root of a number is the same as raising the number to the 1/2, you can rewrite this expression. So they just change from square root of 5 to 5 to the 1/2. Using the powers rule, you multiply the exponents together. So this is 5 to the 3/2. So notice that the index of the original radical, in this case 2, became the denominator. So remember, index means the little number that is right here on the square root sign. We have that in our notes right here. Oh, you can't see my paper. This is why we take notes too. It's really handy. Remember, index is the number that's right here. So when they're asking for this vocab, remember you have that in your notes. So the index of this original number became the denominator. The exponent of the original expression became the numerator. So that's kind of our general rule here on where those numbers end up going. So we're going to write this down. This is like the generic formula. So we can follow that. Let's write that down real quick. So if I have A as my index of x, so like the eighth root of x to the b power. Let me just make sure I write it exactly how they have it. So with parentheses to the b power, that ends up being x to the b over a. So if we just want to do a numerical example, let's do the cube root of 10 raised to the 5th power. It's just a random example I'm coming up with. So that would end up being 10 to the 5/3 power. So that's how you apply that formula. You look at where does the index go, where does the exponent go. Okay, so continue. To rewrite an expression with a rational exponent, so it contains a radical, follow the previous rule in reverse. So what if we want to go the other way? So 7 to the 5/3. The denominator becomes the index of the radical, and the numerator remains the exponent. So this denominator, the 3, that becomes now the index of the radical. And then the 5 just stays as the exponent. The expression can always also be written with the exponent under the radical symbol. So this is the same as this. And that's something I want us to put in our notes real quick. Because sometimes it'll be handy to put the exponent under the radical, and sometimes you'll want to pull it out, and we need to know that we can do that. So I'm going to jot that down in our notes here. I'm just going to put a little star and say, you can do this. Just so you remember that you can do this operation by putting that exponent under the radical symbol if you want to. I'll show you what I just did. So just wrote this down, that this is something you can do. You can take that 5 and put it under the radical symbol if you want to. Okay. So evaluating expressions with rational exponents. To determine the expression of a rational exponent with rational exponents, use the numerator as a power and the denominator as the root of the base. Here's an example. So 64 to the 2/3 power. So we're going to rewrite it using radicals so that we can actually evaluate that number. So 64 to the 2/3 can be written like this, as the cube root of 64 to the 2nd power. Then you can actually start evaluating that. Let's see, what did they do? So they wrote this, the cube root of 64, they rewrote 64 as 4 to the 3rd power just to show that 4 is the cube root of 64. If it was me personally, I probably wouldn't even have that step in there. I would just evaluate the cube root of 64, like using a calculator, or you might just know that 4 times 4 times 4 is 64. So that becomes 4 squared, which equals 16. Helpful hint: when working with larger numbers, it may be necessary to use a calculator to evaluate expressions. Many calculators have this symbol. Yeah, so a lot of calculators will have this. It's called a caret symbol to indicate raising a number to a power. So when you, if you have a calculator that has a caret key like this, that means exponent. So this would be like 2 to the 1/5 power. You may also have to use parentheses when you're doing a fractional exponent, because if you don't use parentheses, it might think you're doing 2 to the first power and then divided by 5. So be really careful when you are plugging numbers into your calculator. And if you need help figuring out how to do that, let me know. Okay, knowing some perfect squares and perfect cubes can make simplifying these problems easier. Practice recognizing these numbers with the interactive below. Okay, so we can drag and drop some things here on what's a perfect square, what's a perfect cube. So I'm going to go through the list first and just see if I know they're perfect squares. Those are usually off the top of my head, like 16 I know is 4 times 4. 5, 8, none of those are looking like what I want. Okay, 25 is 5 times 5. 1 is 1 times 1, but that's also going to be a perfect cube, 1 times 1 times 1. So I'm going to put that in the middle. For some reason, I can't get over here. Let's see. Okay, 64. That's 8 times 8. So now I need to look at which ones might be perfect cubes. So something times itself 3 times. Well, I guess 0 times 0, I guess that should be a both, because 0 times 0 would work for a perfect square and a perfect cube. Although I don't know, it could be a neither. Let's see what they say. 27 is a perfect cube, 3 times 3 times 3. 125 is 5 times 5 times 5. That's a perfect cube. 8 is 2 times 2 times 2. That's a perfect cube. And I'm thinking these are neithers. I don't recognize them as perfect squares or perfect cubes. And I think it'll let us check our answers here. When I scroll down, check answer. Maybe. I don't know. It's not letting me check. Or maybe it means I got them all right. Check answer. Maybe that'll work on your guys's. I'm pretty sure we got the answers right, though. Okay, let's keep scrolling. So now they give you a video to watch. So it's just 2 minutes. Go ahead and go watch that back. You should have the course tab open as well. And you can pause this video. And then there'll be a step-by-step here. So evaluate this expression. So look, it starts getting pretty crazy looking. So that's why it's important that you remember each individual step. Begin with the radical in the numerator and rewrite it. Okay, as the cube root of 216 to the fourth. So what they did is they pulled that fourth power out for some purpose here. So what is the cube root of 216? So if you don't know the cube root of 216, that's where you need to use a calculator. Like Desmos.com, I told you, is one that I like. That's just right here handy. You can use a handheld calculator, a phone calculator. So the cube root of 216. So I'm going to do 216. I'm going to raise it to the power. I need to use parentheses of 1/3. So it comes out as 6. Hold on, I can figure out where it was. There we go. 6. Okay. So now we know the expression can be written like this. 6 to the fourth. We just replace that cube root of 216 with 6. Now evaluate 6 to the fourth in the numerator. Okay, so I need to evaluate 6 to the fourth power. So 6 to the fourth is 1,296. Okay, now the expression can be written like this. Next, evaluate the 32 to the 1/5 power in the denominator. So 32 to the 1/5. That's the same as the the fifth root of 32, which we talked about in it previously, was 2. 2 times 2 times 2 times 2 times 2 is 32. So I happen to know that one. But if not, you can just use your calculator. So now the expression is 1,296 over 2. And now we can actually find that quotient, which would be 6 148, I believe. You could use a calculator as well. That is correct. Okay, so now it's time for you to do your workbook. So just remember those steps that we just talked about and let me know if you have any questions.